Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you through how to solve each of the problems on the Chapter 5 quiz review, sections 5.1 through 5.3. As always, my disclaimer, do not come to the video and just watch it and copy down the answers. I need you guys to work out these problems on your own and then come to the website and the video to check your answers or iron out any misunderstandings that you may have. So my Clemson reference for this video is a little Clemson spinner that I have. And as I spin it, what do you know? It even looks like a tiger paw as the tiger paw is spinning around in the middle. I know. Gotta do it though. Pretty cool. My Clemson spinner. Alright, so let's go ahead and jump right in. What is the sum of the interior angle measures of a 14-gon? The way I taught you guys to solve these problems with interior and exterior angles is to focus on the trigger words. I have the word sum. That's an important word. I have the word interior. That's an important word, okay? Sum of the interior angles. So if we look back at our little cheat sheet, our student guided notes, or if we refer to your book, the sum of the interior angles is going to be equal to n minus 2 times 180. Again, the n minus 2 just represents how many triangles I can split my polygon up into, and the 180 represents the three angles of a triangle that add up to 180. So it's basically the number of triangles times 180. N stands for the number of sides, and in this case I have 14 sides, so I just plug in 14. That will be 14 minus 2 times 180. Plug that into your calculator and you end up with 2160 degrees, 2160 degrees. Remember, if you plug this into your calculator, yes, you can just do 14 minus 2. You can just do 12 times 180, and that's fine. If you plug this into your calculator exactly the way you see it, make sure you put this in parentheses so the calculator doesn't mess up the order of operations. Okay, number 2, what is the measure of each? Okay, that means only one. Each interior angle. Okay, each interior. This is the formula that we're going to use the same formula, the sum formula, n minus 2 times 180. That gives me the sum of all of the angles of this pentagon, but then I want one of those angles, so I'm going to divide by the number of sides that I have, which in this case, I'm going to divide by n, which in this case is 5. So since it's a pentagon, everywhere I see an n, I'm just going to substitute a 5. So this will be 5 minus 2, which is 3, times 180 divided by 5. So in your calculator, you can just type in 3 times 180 divided by 5, or make sure you put that in parentheses, and that comes out to be 108 degrees. Now remember, both of these formulas, whether it's interior or exterior, where I'm dividing by n, that only works if I have a picture-perfect, perfectly symmetrical, or we call it a regular polygon. So this is a perfect pentagon. Okay, number 3, I'm missing an angle here. I'm missing that guy. So we're being asked to find the measure of angle C in this pentagon. Now I can't use the formula that I just used because once again, that only works with a perfect polygon. This is obviously not a perfect polygon because a regular polygon means it's equilateral and equiangular. Obviously that's not the case because all these angles are different. Okay, so I'm going to have to go back up and use my sum formula. I want to find the sum of all of the angles of this pentagon, so I just plug in a 5. 5 minus 2 times 180. 3 times 180 gives me 540 degrees. Okay, so every pentagon on planet Earth, every pentagon, all the inside angles always add up to 540, whether it's regular or not. Okay, so to find the missing angle, I just simply need to subtract the other 4 angles. Okay, all 5 of these add up to 540, so I just subtract this one. That's a box, so that's a 90-degree right angle. I'm going to subtract that angle, so minus 105, minus the 86-degree angle, minus the 137. Plug all that into my calculator, and I get 122 degrees. And again, make sure you do that self-check, that gut check. 122, do you buy that angle, that obtuse angle is 122? Does that make sense to you? Yes, it does. I buy that. Okay, so if you had done this wrong, if you'd picked the wrong formula or plugged in the answers wrong in your calculator and you got something like 212, you said, hold on, wait a minute, I can't have an angle that's over 180. Or you plugged something in wrong, you got like 10 degrees. And like, wait a minute, let me just think about this a second. Maybe I made a mistake. But 122, I buy that. Okay. Of course, you could check your answer and add 122 plus 137, add all 5 of them back up and make sure they add up to 540. Okay, number 4 says, what is the measure of an, okay, that means one single each exterior angle of a regular pentagon. What is one of these outside angles? Well, one of our formulas in section 5.1 about polygons says that the sum of all the angles of any polygon is always 360. Doesn't matter if it has 6 sides or 2,000 sides. They all add up to 360. If I want to find just one of those guys, then I'm going to take 360 and I'm going to divide it by the number of sides that I have. And again, this only works if I have a picture perfect regular pentagon or regular polygon, which in this case we do. We have a perfect pentagon. So I'm just going to divide 360 by the number of sides, which in this case is a pentagon divided by 5 sides, and I get 72 degrees. Okay, that's pretty easy. All right, next one down here we have, okay, we did this one in class. It says 2340 is the sum of the interior angles of a polygon with n sides, and we're being asked to find the number of sides, find n. Okay, so I'm going to use my sum formula, n minus 2 times 180, that equals the sum. Okay, well, normally we're trying to find the sum, but in this case we've been given the sum. We already know what that is. They tell us that. The sum is 2340, so I'm just going to plug it in here. So 2340, the sum is equal to n minus 2 times 180. Okay, now how do I solve this? Yes, you could distribute the 180 to both of these in the parentheses and work it out, but that's just going to create a couple extra steps for you. Really don't need to do that. All we need to do is just divide both sides by 180. The 180s cancel, and so I'm going to be left with n minus 2 equals 2340 divided by 180. Plug that into your calculator, and you get, slide this over, you get 13. Okay, so then I'm going to have to add 2 to both sides. Why am I adding 2? Well, remember, 13 is just the number of triangles that I can form because I'm dividing by 180. So I got 13 triangles, but the number of triangles is always 2 less than the number of sides. That's why we're basically, algebraically, we're having to add 2 there. So I'm actually going to get a 15-sided polygon. Okay, n minus 2, that means 13 triangles, but the number of sides is 15. Okay. All right, so remember, when you're working backwards, you're basically going to divide by 180 and you're going to add 2 to get the number of sides. Okay, so number 6 here, number 6. What is the measure of angle O and parallelogram in LMNO? Okay, well, I know if it's a parallelogram, that means opposite angles have to be congruent. Okay, opposite angles are congruent. You can use the little trick that I taught you from chapter 2. All of the big angles are the same. All of the little angles are the same. One big plus one little, one obtuse plus one acute has to equal 180. Well, what is angle O? L is obtuse. Obviously, it's 106. What is O? Is that little or big? That's acute. These are consecutive angles. They're same side interior angles. One big and one little, that means they have to add up to 180. Okay, so I'm just going to do 180 minus the 106 minus the obtuse angle, and that will leave me with 100. That's going to leave me with 180 minus 106 is 74 degrees. Okay. All right, so if this is 74, let's go ahead and just fill in the other angles, even though they don't ask us for that. If that's 106, what is angle N? These two are big, so both of these are 106. This is little, that's little. Both of these are acute angles. Both of these will be 74 degrees. Okay. All right, let's flip on over to the back. And we have our big bad system of equations. Find x and y for the following parallelogram. Okay, if it's a parallelogram, that means opposite sides are congruent. They're the same length. So that means these two guys have to be the same. The top and the bottom have to be the same length. So I'll set those equal to each other. So y equals 4x minus 5. Okay, I can't solve that equation. I have two unknowns. I have two variables and only one equation. If you have more variables than equations, you're stuck. You're stuck in the mud. You can't do anything with that. So that means I'm going to need another equation. That means I'm going to need to come over here to the left and the right. These opposite sides are also congruent, so I'm going to set those expressions equal to each other. 2y will be equal to 2x plus 2. Now, 3 ways to solve a system. Elimination, substitution, graphical. You can do it with matrices. You guys will learn about that in a couple of years. But you guys have only learned substitution, elimination, and graphical. Okay. Substitution is going to be easier here. Anytime you have one of your variables that's already isolated all alone by itself on one side of the equation, like we do up here in the top, substitution all day long. Okay, y and 4x minus 5, they're interchangeable. Okay, they're exactly the same. So everywhere I see a y, I can replace that with a 4x minus 5. So in the bottom equation, I got a y right here. I'm just going to stick in a 4x minus 5 right here. So in the bottom equation, I have 2 times y, but what is y? Y is equal to 4x minus 5. So I'm just going to substitute 4x minus 5. And then that's going to be equal to the right side of the equation, 2x plus 2. Okay, I'm going to use the distributive property here. 2 times 4x is 8x. 2 times negative 5 is negative 10. That's going to be equal to 2x plus 2. I want a positive variable, so let's move the 2x to the other side, so that will leave me with a positive 6x over here. Minus 10 equals 2. Let's move the 10 to the other side. I get 6x is equal to 12. Divide both sides by 6. And I get x is equal to 2. Okay. Now, they want me to find the value of y. So I'm going to plug this back in. Where do I plug it back into? This equation, where do I plug it into? I'm trying to find y, so let's plug it into the one where y is already by itself. So I'm going to take this 2 and stick it right in there for the x. So y is going to be equal to 4 times x, 4 times 2, and then minus the 5. That's 8 minus 5. Y is equal to 3. So x is 2, y is 3. Let's check our answers. Just for grins and giggles, let's plug it back in and make sure they're equal to each other. Y is 3. Okay, so that means the bottom length better be 3. 4 times 2 is 8. 8 minus 5 is 3. Okay, so that checks out. The left and the right better be the same length. 2 times y, 2 times 3 is 6. And then 2 times x, 2 times 2 is 4. 4 plus 2 is also 6. Okay, so that checks out. So take those few extra seconds, guys, on your quizzes and tests, and go back and plug your answers back in on all the ones that you can to check and make sure you didn't make a careless mistake somewhere. Okay, number 8. This is the one we did in class with the yardsticks. So if the yardsticks are all spaced out evenly apart, then I know that each of these distances are the same. All right, so they're telling me that GH, HJ, JK, KL, they're telling me all these little pieces in between my parallel lines, or in between my rulers, yardsticks, however you want to think about it, all these little distances are the same. I don't need to know what the numerical value is. I just need to know all those distances are the same. I mean, they could tell me this is 4, 4, 4, 4. That just means all these parallel lines are equally spaced apart. Okay. So then they tell me MQ, this whole length, this whole guy in purple, that whole thing is equal to 29.5. 29.5. Okay. So if the whole thing is 29.5, how do you think I get each of these little 4 pieces? They're equally spread apart, so why don't we just divide 29.5? Let's just divide that by 4. Okay, so MN, one of these little pieces, that's what they're asking for. They want just one of those. MN is going to be equal to the whole length, 29.5, divided by 4 parts. I got 1, 2, 3, 4 different parts. And that gives me 7.375, 7.4, however you want to round that. Okay. All right, so let's look down here at the bottom, just a few more. For what value of A must element O be a parallelogram? Okay. Well, I've got some A's and I've got some B's here. All right. Let me blow this up a little bit. It's kind of hard to see. Okay, so I've got some A's and some B's. Well, if it's a parallelogram, that means opposite sides have to be the same length. So I could set 2A equal to 2B plus 1. But once again, that doesn't really help me because I have 2 different variables and only one equation. So why don't we set the 2 top and the bottom expressions equal to each other, because both of these have a B in it. So I'm going to say this guy and this guy are the same. So I'm going to set 4B plus 7 equal to the bottom expression, 8B minus 1. Okay. And I can solve that, so let's move the 4b to the other side, so we have a positive variable. 7 equals 4b minus 1. Let's add 1 to both sides. 4b is equal to 8 divided by 4, and we get b is equal to 2. Okay. All right, so now I can go back, I can take this 2 and I can plug it in right here. Okay. 2 times b, 2 times 2 is 4, and 4 plus 1 is 5. So that length is 5. And now I can set the 2a equal to this side. I'm going to set 2a equal to the 2b plus 1, but I've already substituted it back in. 2 times 2 plus 1 is 5. So 2a has got to be equal to 5, the right side of this parallelogram. It's got a length of 5. So I just divide by 2, and a has got to be 2.5 or 2.5. Again, you could go back, plug your answers back in. For sake of time in this video, I'm not going to do that, but you guys could plug your answers back in and make sure that opposite sides of that parallelogram are indeed congruent to each other. All right, zoom back out a little bit. All right, number 10 says find x and y for the following parallelogram. Okay, so this is where I taught you guys to match up your x's and your y's. Okay, I've got an x up here in the top left, I've got an x up here in the top right, and I don't have any other y's. I can't really match up anything for the y's, so let's focus on the x's first. That angle, is that big or little? That's little, that's acute. This angle, is that big or little? That's big. So when I have one big and one little, that means they're supplementary. So that means this guy, the 3x plus 10, plus this guy, the 8x plus 5, they got to add up to 180. So I'll set up an equation, 3x plus 10 plus the x plus 5, all of that has to be equal to 180 degrees. Combine your like terms, 3x plus 8x is 11x, 10 plus 5 is 15, equals 180. Let's subtract 15 from both sides. 11x is equal to 165. Divide both sides by 11, and I get x is equal to 15. Okay. All right, so that's one of our answers, and now we got to go back and we got to find y. Okay. So there are two ways to do this. You could look at these consecutive angles and set them up to equal 180, but I think it's probably easier just to set the opposite angles equal to each other. 5y is also a big angle, so these two big angles have to be equal. So 5y and 8x plus 5 have to be the same. So I'll set up another equation. 5y equals 8 times x, but we already know what x is. We just solved for it. X is 15, and then plus 5. So 5y equals 8 times 15 is 120. 120 plus 5 is 125. Divide both sides by 5, and we get y is equal to 25. Okay, 15 and 25. Okay, and the last one here. Again, go back and plug these back in and make sure that opposite angles are the congruent and make sure consecutive angles add up to 180. They're supplementary. Last one says quadrilateral QRST has two pairs of congruent sides. Is it a parallelogram? If not, what additional information do you need to conclude that it is a parallelogram? Two pairs of congruent sides. Well, that sounds like that's a parallelogram, right? If you tell me two pairs of congruent sides, you tell me that's a length of 7 and that's a length of 7. You tell me this is a length of 4 and that's a length of 4. Our theorems say, well, shoot, that's a parallelogram, right? But what if the sides that they're talking about, the two pairs of congruent sides, are not across from each other? What if I had a parallelogram that looked like this? What if I had double ticks and double ticks, single tick and single tick? What if this is 6 and 6 and this was 7 and 7? Is that a parallelogram? No, it's not, because opposite sides are not congruent. So the answer to this question is no, not necessarily. I'll say no, not necessarily, because the two pairs of the two pairs of congruent sides could be consecutive. They could be beside each other. What I would need to know to make sure, to ensure this is a parallelogram, is I would need to know that these pairs of congruent sides, I would need to know that they are either across from each other, okay, or I would need to know something about the angles, all right? And that would allow me to say that this is indeed a parallelogram, okay? So that's it for this video. Hope you guys enjoyed that, and I wish you good luck on your quiz, and we will see you on the next one.